Yeah, basically my name is Martin, Martin Gwarada. So I'm going to talk to you about Apache Spark, particularly machine learning, the machine learning library in Apache Spark. Just a quick question. How many of you have used Spark before? Oh, that's good. And what about machine learning in particular? All right, interesting. Okay, hopefully I won't bore you. But basically, reason I sort of like wanted to find out is, as the title says, you're applying Spark's machine learning to a multi-vector problem. So I was sort of like working on something on a recruitment problem. And this recruitment problem, I was trying to match candidates to jobs. But then as you all know, candidates, naturally you've got a lot of skills that are very varied, even just within computing alone, right? You have varied skills. Some people even just not only looking at the skills, but some people the way they would describe their job titles. Someone could be a developer, right? And they would probably put that an engineer, for instance. So how do you match that to a job that says maybe I'm an architect, something along those lines? So that's the issue I was facing. So I'm not going to bore you much with definitions, but I'll just read this one out to you. So machine learning, as we all know, it's a process of gaining an understanding of the data available using computer algorithms by finding patterns in the data and then predicting probable outcomes. And then types of machine learning, obviously you've got supervised learning, whereby your inputs, you've got inputs as well as outputs, and then you're trying to sort of like get the model, which you then apply to your data. And so we've got classification, and then we've got regression, and then we've got unsupervised learning. Unsupervised learning is where, unlike supervised learning is when you've got, you're trying to from your data, you sort of like trying to find patterns within your data and then somehow build your model based on that. So you give an input data, but then you don't have output data, so you're trying to find more patterns within that. Then we've got reinforced learning. This is whereby this tends to happen with robots, a lot of times with robots. For instance, you might have a situation where like the iRobot. How many of you are aware of the iRobot, the vacuum cleaner? So like, for instance, it might be going around the room. So it's like, as soon as it hits the walls, next time you know there's a wall. So that's kind of like reinforced learning. And then we've got recommender systems. We all know about those, like Netflix have used those. Most retailers, online retailers. And then, but they've got collaborative filtering, which I'm going to focus on today. Semi-supervised is a mixture of supervised and unsupervised learning. Yes, so generally, right, a typical machine learning model creation, so you tend to sort of like follow these 9 steps. So you first sample your data, you process the data and add any missing data, split the data, training and your testing data, predict with training data set and observe the results using the, and then number 6, use the test data and evaluate your model. You tune the model for accuracy, and so you sort of like keep on repeating. So where you're tuning your model, right? It's like you're going back again to number 3. So you split, if you've got more data, you split it again, and then you follow that time and time again until finally you're happy with your model is giving you like a good enough accuracy. After that, and then number 8, you then scale up your model now. So now you're going into production. You scale up your model. You're using typically, or in other words, you're putting it into production. It's going into the mass market. That's number 9, which is deployment to production anyway. So I'm going to discuss how we can sort of like how I used Apache Spark to apply it to a recruitment problem that I was having, the issue I was having. So first of all, just to, for those that do not know what Apache Spark is, Apache Spark is just generally a library that's it's got other things within it, right? But then generally it's used to it's an engine that's used to suitable for analytics, advanced analytics. It can chunk in a lot of data, so it's used mainly on big data. And the advantage it has is it's very fast. For those that have used it, I suppose majority of you have heard of Hadoop, right? So Apache Spark, for instance, they claim is 100 times faster than Hadoop, right? That is if it's in memory, because a lot of times what it does, it puts a lot of the data in memory, right? And it chunks up the data in there. And then if it's on disk, it's up to 10 times faster than Hadoop. And then with Apache Spark, also the advantage it has, right? As you know on this diagram, the advantage with Spark is that instead of, so you have a driver program, and then you've got a cluster manager, and then you've got some worker nodes. So the worker nodes tend to do the work naturally. So in the worker nodes, that's when you've got like an executor in there. So what happens is, instead of data coming into the driver program for it to be worked out, that's expensive because you're looking at network. It's expensive for the network. So what tends to happen with Spark is the code actually goes to the worker nodes, and the worker nodes. So instead of data is on the worker nodes. So you don't want to move your data to the driver. So what you tend to do is, since data is already resident on the worker nodes, Spark allows you to move the code to the worker nodes so that the code actually works on the worker node right there, and it only brings back the results. So at least your results, it's not bringing back everything. So for instance, as a typical example, like a hello example in machine learning, is like, say, counting, for instance, like you've got like a big document and you're trying to count the number of words, right? If you think about it, say you've got like several encyclopedias. Remember the old encyclopedias. So you've got 10 encyclopedias, there are another 10 here, and you're just counting words. Instead of bringing back that whole encyclopedia to the driver, all you want to do is count on the worker node. This will give you, say, 10,000 words, another 10,000 words. And then all that comes is just an int, a number. So that way, it's faster. It's not expensive on the network. So what I'm going to use for this task or for this problem, I'm going to use collaborative filtering, which is a type of recommender system. So again, mainly collaborative filtering is used by companies like, it's used, like, for instance, it was used in the Netflix problem. I don't know if you heard of like the Netflix problems where they gave, it was a competition where they were going to pay someone $1 million. Some of you might have heard of it. And they use collaborative filtering. So in that, right, in collaborative filtering, what they also use is something called alternative least squares algorithm. So all it is basically is, with alternative least squares algorithm, all it is, they tend to have two data sets. So in that, what you do is you create like a vector, a matrix vector. So you create one matrix vector, right? And then you iterate on that. You get an answer for that. Like, so you get like sort of what they call like an RMSE. So basically, like, you get like a form of accuracy from that data. You keep it there. You get the second vector. You iterate on that. So you keep comparing these two matrix vectors until you can sort of like converge to a good enough sort of like, a high degree of accuracy at least. So this is what it is. This is the formula for alternative least squares. So in actual fact, you mention your, you put your iterations, the maximum number of iterations. A regular parameterization, all it is to ensure that your data, they call it, to ensure that your data is not overfitting. What that means is, if your data at any point, right, you don't want your data to sort of like just be able to explain one data set so that if you move it to a new data set, it won't be able to apply. So in my case, for instance, if I'm going to use my data set is just computing, I don't want my data to overfit just computing as a sector, for instance. I want it to be able to be applicable to any kind of data set. That's all it is. So, and then you then state either, so we've looked at this data set, so we'll either state your user column and your item column. So candidate ID for myself and job ID. And then you set where your score is. So these are some of the results that I got. I'll show you the code afterwards. So as I was iterating, so what I'm trying to achieve is the least RMSE, which is the root mean square error. So I'm trying to achieve the least. But then, so for each of the different iterations, I could have gone on forever and ever, right? And changed also the regularization parameter. But then, so at 5, I got 2.6. At 10, 2.56, and it kept on going down, right? However, ideally, ideally, you want a score below 1. So my scores, they're not good enough, basically. Ideally, you want a score under 1 for you to say your model is good enough, at least so you can take it to production. Yeah. So in this case, I could have continued until I got a lower score, a lower RMSE. However, you also need to take into consideration that at some point, right, no matter how many iterations you start adding on, right, you might not, your score might not end up going down. Right. So what you tend to do a lot of times, it means either your model is wrong, so you go back again. So in those steps that I showed you, you end up having to go back again, or either it means maybe collaborative filtering doesn't apply to your problem. So you end up having to use another, through experiment, having to use another algorithm or another machine learning algorithm, So here are my results. So, for instance, so these were my candidates. So I had a candidate, say, for instance, property manager, right? And these are the recommended jobs. For some of them, you can tell, like, obviously, like in this case, like, so the higher it is, the more they match. So basically, a property manager, what my model is basically saying is a property manager can take up any of those roles, can become a science teacher. So there must be something wrong there, depending on the skill. Lead production supervisor, software developer, someone who's retired. I think maybe that person might have been in IT or something. Says DevOps or second help desk, IT manager. So, but then you can tell from my results, right? So that some of them are not quite as good. It's mainly also because my RMSE is not good enough. So it means in that case, the conclusion to this is, in that case, it means I need to use a different model or a different algorithm, or it might mean that I would need to combine a few algorithms together to achieve, to find a solution, to find a model for my problem. If I just quickly show you the code and explain the code. So, first of all, here's the. So that's my data. It was in a CSV, and that's my candidate's data. And if I show you, yeah. So here's the code. So all it is. So first of all, can you see at the back? Is that slightly better? Yeah, so all it is in my code. By the way, for some reason, Spark, right? I haven't worked that one out. Spark doesn't allow you to use to extend up. So you have to put it in the main method, whatever you're doing in Spark. You have to put your code in a main method. But anyway, so first of all, the first thing that I done was to get the data. So my data in that case is matching scores in a CSV file. So SC, so it's sc.text file. So that's a Spark context. So I get that data. And then at the same time, I create a case class where I'm going to put my data, right? And then finally, I create an RDD. What an RDD is just a resilient distributed data set. So in, I'm not going to go, I'll show you detail, like you can read up on our resilient distributed database because I haven't got time to describe that. But all it is just basically, you can say it's sort of like these are units that I used within Apache Spark, where they keep data inside this resilient distributed database. What it is it can be stored, because a lot of times you're using clusters in big data, in machine learning. A lot of times you're using clusters. So you can store your data sets in different, it could be in different clusters, but it's all one data set. That's all it is. So here I convert it to an RDD of type string. Convert the RDD of type string into, RDD matching score from this case class that I created. And from then on, I create so first of all, I create a data set. And then here at this stage, I'm creating a data frame. The difference between data set and data frame is that the data frame, a data frame tends to have columns. It tends to be more like a table, hence why I'm able to run SQL queries on it. So that's why you find here, I'm running sort of like a SQL query, select, count, whatever, from matching score. So you can use that. That's Spark SQL. So here I divide my data. Remember I mentioned that like in one of the steps, as in you need to divide your data, as in you have to have your training data as well as your testing data. So in this case, what I'm doing is I'm dividing my data, I'm splitting it. 0.7 is for my training data and 0.3 for my testing. And then so right here now, what I'm going to train my data. So now using that training data that I got, I'm going to train that using the alternative least square algorithm. So once again, that's the one that I'll use to. That's the one that I'll use. So because I've divided my data into 0.7 and 0.3 of the data, and then I'll use the training data now to create my model. And then at this stage, so this fit, ALS fit, so here I've created the algorithm. Here, ALS fit training data. So here, that's where I'm actually doing the training of the data, training of the model. So here I've created the model, I'm training the model, right? Once I've done that, somewhere down there, I test, because before, since I had split my data, the 0.3 that I've kept, right, for training, for testing the data. So now I'm testing the model to see if that model is fit for purpose, basically. So that stage. So if it's not, that's when I go back again and change the iteration. So as you've noticed, because I started off doing 5, 10, and then 15 iterations. So is this place here where I'll be changing different parameters, putting in different parameters. So for instance, in this case, I'm starting off with a 5, and then I change it again, and I test it here to test the prediction. If it's still wrong, or if it's still sort of like the accuracy is not good enough, then it means I'll continue retraining it until I can sort of like get a better RMAC. So here at this, right at the bottom here, what I then do is So this, I'm creating here I create an evaluator. So it's a regression evaluator. So all I'm doing is I'm setting the metric name, which is RMEC, root RMEC. So I create the evaluator here, and I create the label. It's going to be code, and I give it a prediction. I set the prediction column there, and then I work it out. So here, this is the part where if it's say I'm trying to achieve anything below 1, if it's anything above 1, right, that means I'll continue going back again, retraining the data or using other data that I would have kept aside or something along those lines until I can get a good enough score. And right at the end, I then create the model for all users and or for all items basically. Any questions? I know I went through it too fast. All right. Anyway, I will probably say, with regards to so basically for this work, all the tools that I used obviously Spark, Apache Spark, but then in addition to that, you can use tools like Zeppelin. Zeppelin is actually very good for sort of like showing your results and sort of like going through your results so you can analyze your data better and things like that. Thank you.